So my presentation is about prefabrication for improving construction productivity and housing quality. My two challenges, I think I mentioned them earlier. The first one is declining productivity, and I want to link that particular challenge with labor shortage and how we can, in a sense, address them a little bit by attracting and retaining women, and also by improving health and safety in the construction industry. The second one is poor quality. Well, in a sense, it's about alleviating the time pressure demand in construction, and because of the weather dependency as well when we work on site. So if we can transfer some of the work from site to the factory controlled environment, then we can be more released in terms of the weather dependency, quality of the workmanship, and also constructability issue. So I just want to give a case study, well, two case studies actually, and this one has been published there. This one is an 8 townhouses project in Melbourne, and we collaborated with Merfac in doing this research. So we compare the performance of those townhouses. So 4 were built using prefab, non-volumetric, so the floor and the walls were built using prefab, and then we compare their performance with 4 conventionally built houses. And this is the result. So we can see different indicators there, and we can see the comparison between traditional construction and prefab construction. In terms of duration, we can reduce the duration from 29 weeks to 22 weeks. So it's a 23% saving. The floor structure, so just to build like one floor structure, in traditional, the workers needed 12 hours, but for prefab, it's only 1 hour. So much quicker. The labor hours, we also can reduce from more than 8,000 to roughly about 7,000. So it's a 11% saving. The work on scaffold. In traditional construction, the workers spend 12 weeks to work on scaffold, while for prefab, we can reduce the number to 7 weeks. So as a result, it's safer construction, right? Because people were not working at height. Manual handling can be reduced very significantly from more than 2,000 lifts to install 42 tons of material, while for prefab, everything was lifted by crane. So this is very important because it reduced injuries related to manual handling. And injuries because of manual handling is the #1 type of injury in the construction industry. So if we can reduce manual handling, automatically we can increase productivity. On-site waste, likewise, from 22 ton to 11 tons, so roughly about 50% reduction, because then when we work in a factory, we can control the waste better as well, even in terms of the recyclability of the waste. The community is less impacted because of less worker cars, and then less traffic and less pollution. And lastly, in terms of air tightness, in a sense, it's a proxy of quality. For traditional construction, it's 8 air changes per hour, and for prefab, 5 air changes per hour. So in terms of the air tightness of the building, the townhouses built using prefab are actually better than traditional builds. The second case study. So this one is using bathroom pots, again in Melbourne, also by Merfac. And we again compare the performance of prefab and traditional build. This is the final finish of the bathroom by using prefab. And we also captured the performance using video footages. So the one on the top left is obviously prefab, and the one on the bottom left is using traditional approach, so in situ approach. Okay, in traditional bathroom construction, the project team members, including the project manager, site manager, project engineer, site supervisor, and health and safety coordinator, they need to manage the work of 9 trades. And the 9 trades are plumber, electrician, plasterer, joiner, glazier, waterproofer, tile supplier, and fixture suppliers, just to build a bathroom. So they need to coordinate and manage their performance by doing those 8 activities: tendering, purchase order, schedule management, document control, calls and emails, inductions, and health and safety management. Again, just to build a bathroom. And they need to manage the quality performance in terms of inspection, warranty, certification, and defect management. So a lot of works just to build bathrooms. In comparison, when we use prefab, there's one company. So in this case study, the company is called Sink, the bathroom pots manufacturer. So the project team members simply coordinate with one company in terms of design, detailing, tendering, orders, delivery, and inspection, as well as the quality control activities, warranty, certification, and defect management. So the overall process, in a sense, is simpler. And this is the comparison between prefab, the one on top, the one below, and traditional is the one on top. For scheduling notification, we can reduce the number from 460 to 104 notifications, so 78% reduction. The amount of calls or the number of hours in making phone call, we can reduce from 61 hours to only 15 hours when we use prefab to build bathrooms. In terms of emails, from 930 to 52 email only. The amount of meetings, 130 hours to 78 hours, 40% reduction. And lastly, the amount of time spent in doing inspections, we can reduce from 360 hours to only 104 hours. So clearly, we can see the benefits of prefabrication. A bit more. So remember the video footage. Here, we just capture the movement of the workers in prefab and in traditional construction. In traditional construction, in terms of entries and exits, so it means the amount of time a worker is going inside the bathroom and going outside the bathroom to do whatever inside the bathroom, to construct the bathroom. For traditional construction, more than 21,000 times to go inside, going outside, inside and outside. For prefab, we can reduce the number very significantly to only 520. The same, the number of workers, more than 3,000. For prefab, only 156 workers. Man hours or labor hours, almost 3,000 hours for traditional construction, and we can reduce the number of hours to only 37 hours when we use prefabrication, and likewise the days in construction as well, 94% reduction. So very clear benefit. And lastly, this one just a comparison in terms of mental health, again, has been published in this paper. I'm promoting myself. Yes, so this example is just about management stresses, and we can see the comparison between traditional and prefab. So we survey the workers, and interestingly, we can see that prefab workers are less stressed out in terms of experiencing those stresses than the traditional workers. Just some example, that one, job resources. So prefab workers felt better in terms of the resources that are provided for them. They experience better management directions, better communication, even in terms of the shift rosters as well, less work overload, less undue and excessive criticism, and so on. So even in terms of mental health, somehow prefab workers experience better than traditional workers. So just to summarize the findings of the research, we can see the benefits of prefab from different indicators or dimensions, I suppose. The first one, very clear, it can reduce construction duration. It's proven. So this is the time spent on site, because obviously the activities are transferred to the factory environment. And the second one, there are some environmental benefits, because we can reduce construction waste. We can reduce pollutions. Automatically, we can reduce carbon emissions as well. And because of the better quality, the prefab homes have more durability. The better quality, because the work is done in a controlled environment, enabling better quality control. Better health, the long-term health, especially musculoskeletal disorders, and also better mental health, which is a very important I suppose, aspect in the construction industry, because the industry is well known for its poor mental health. And better safety, less exposure to safety risks, less work at a height, less manual handling, and less muscular stress, which is extremely important because, again, as I mentioned earlier, that's the number one type of injury in the construction industry. The workers also enjoy some benefits, reduced worker demand because, less requirements in terms of coordination and management. By having a better work environment, we also can attract women because of less physical labor and safer work environment. And at the end, prefab also can lead to better retention and worker satisfaction. It sounds so wonderful, but we need to acknowledge the challenges to prefab, and I think can be applied to other technologies as well, into a certain extent. Number one is always mentioned many times, prefab usually, in most cases, will be more expensive than traditional construction. Why? Some of the factors. We have limited manufacturing capability, especially, unfortunately, in Australia. If we have a prefab factory in Victoria, for example, but then if we need to transport the components to Western Australia, then that will increase the cost very significantly. And even in our prefab factories, usually they use less automation, so they still depend on manual labor, which again can increase the cost significantly. Prefab may introduce new health and safety risks, for example, by the use of crane, and automatically the use of equipment will introduce new health and safety risks. Human resource development is an issue as well, because the construction industry in Australia is dominated by small construction firms. I think 98% of construction businesses are small businesses. So they have limited resources to implement new technologies. And there is a study showing that small organizations, in terms of the revenue per capita, is much worse than large companies. So that's another issue where which limits the ability of small organizations to adopt new things. Lack of standardization, people want this and that, and then the market perceptions and expectations is another barrier in terms of implementing prefab, because people have negative perceptions, in a sense, towards prefab homes. That should be my last one. Thank you.